Okay, Jai Hind guys. So now we are starting with lesson number 3 of geometry, which is circle. The theorem of this chapter is converse of tangent theorem. So what is it? A line is given, means theorem. What is that line? A line perpendicular to a radius at its point on the circle is a tangent to the circle. We have to prove this line L is tangent to the circle. Circle with the point of radius is M. So we have to prove that this line L is a tangent. So first of all we will write here given. What is given? Then given, then to prove, and then proof. In this theorem, separate construction is not given. So what is given? M is the center. M is the center of the circle. M is the center of the circle. M is the center. M is the center of the circle. M is the center of the circle. M is the center of the circle. And segment MN. Segment MN is a radius. And segment MN is a radius. And segment MN is a radius. Segment MN is a radius. So what we have to prove? I mean one more it is known line L is perpendicular to segment MN. Now write these two. Line L is perpendicular to segment what? MN. Then next what will come? First given, then to prove. So what we have to prove? We have to prove that line L is a tangent to the circle. Line L is a tangent to the circle. Line L is tangent to the circle. Then what is come means point after to prove it is come construction. But in this theorem construction is not given, so directly we have to prove. What is proof? In proof we have to write the construction only. Take any point on line L other than point N. Take any point on the line L other than point N. Take any point other than N on the line L. Draw a segment from M. So if we will take the point as a P, in your textbook it is also taken that point P. We have taken point P on line L other than N. Other than N means leaving L ला सोडून दुसरा पॉइंट घ्यायचा आहे त्याच्यावर त्या लाईनवर L लाईनवर. सो आपण पॉइंट P घेतला आणि आपल्याला M पासून ते P पर्यंत एक सेगमेंट ड्रॉ करायचे. सेगमेंट म्हणजे लाईन ड्रॉ करायची. आता हा झाला ट्रायंगल MNP आणि MNP म्हणजे अँगल MN झाला, हा परपेंडिक्युलर झाला 90 डिग्री. पेज नंबर 52 वर हा थेरम आहे. सो बघू शकता तुम्ही. So we will write the proof. What is the construction and proof? So we don't have to write this separately. Take any point. take any point P, take any point P other than M, other than N, other than N, other than N on line L, other than N on line L, on line L, draw segment MP, draw segment MP, draw segment MP. So now the main, this is the point which we have taken, I mean construction. Now the main line comes, main part of the theorem, which is we have to prove. Now which triangle will come? Now in triangle M and P. Now in triangle M and P, angle N is the right angle. Now in triangle M and P. M and P means which the triangle which has created by the construction. In triangle M and P, in triangle M and P, angle N, angle N is a right angle. Is a right angle. Angle N is the right angle. So angle is N is a right angle. So what will be the MP? I have told that in previous theorem, which is of hypotenuse Pythagoras theorem. So when it is when the other MN will be perpendicular, N will be the 90-degree angle. So what will be MP? MP will be hypotenuse. What will be the MP? MP will hypotenuse. So segment MP, it's getting segment MP is hypotenuse. Is hypotenuse. Is hypotenuse and segment. So segment MP is the hypotenuse, and I have proved that MP means MP square is equal to, in Pythagoras theorem, MP square is equal to Mn square plus NP square. Means which one is big? MP, segment MP is big. MP is big than segment Mn. So next point will segment MP is greater than Mn. Yeah, you are getting. Segment MP is greater than segment Mn. Now you will not get, just a minute. So I'm sorry. Hope so you are getting. Yeah. So what will be the next point? That we have proved that segment MP is the hypotenuse and segment MP is greater than Mn. Segment MP is great. So what will be the next point? As segment Mn, as segment Mn is a radius. It is given in the given of the proof. Sorry, it is given already. So as segment Mn is a radius, point P can't be on the circle. Point P, I will write here down. Point P sorry can't be on circle. Can't be on circle. No other point except point N on line L. No other point which is written here. N is right angle. So I have to write what I have tell you. No other point other than N. No other point except point N. Except point N except point N will be on circle. Except point N of line L is on the circle. N of line L is on the circle. Is on the circle. Is on the circle. So line L intersect the line L intersect the circle at point N, at only point N. And this point P is not on the line. So what this point will come first, this point will come second. So now third point. What I have tell you? Line L intersect at only point N on the circle. At only point N on the circle. At only point N on the circle. So we have proved that line L is the only intersect at point N at the circle, and the point P is not coming on the circle. It is other than circle point. So we can prove that what we have to prove, line L is a tangent to the circle. Line L is a tangent to the circle. Hence proof. That's it for the theorem. Now we are taking the small example of lesson number 3. So continuing with the circle solved example. So I have written the question here. You can see it is in the adjoining figure. Circle with center D. Circle with center D touches the sides of angle ACB. AC means which angle come? This angle. ACB at point A and B. This is given. One thing is also given. If angle ACB is 52 degree. Angle ACB is 52. Then find measures of angle ADB. Angle ADB is which we have to find? Angle ADB we have to find. So I have written here 52 and we have to find angle ADB. So solution. So it is adjoining figure circle, and this one is, you can see, it is quadrilateral angles. I mean 4 angles are given in this angle. First angle ACB which is 52. So next angle ACB first come, angle CBD means this angle B. Then angle BDA. This which you have to find, and angle DAC means this. So there is four angles in this circle. The sum of all angles of a quadrilateral, the sum Sum means addition. Sum of all angles of this quadrilateral QU. Just a minute, guys. QUA DRI L8PERAL. I know the spelling, just confirming for you. Is 360 degree. The sum of all the four angles will be of 360 degree. So angle ACB is given, which is 52 degree. So which four angle? Now we will see which four angle. Angle ACB, which is 52 degree. Angle ACB plus angle CBD, or you can write DBC, whatever it is. CBD, angle CBD plus angle, this angle we have to find, angle D, means angle BDA we have to find. So we will write at the end. So remaining angle DAC, angle DAC plus angle which we have to find, angle DBA or ADB, angle ADB, angle ADB is equal to 360 degree. Just wait. Yeah. Is equal to 360. So next point will come. Angle ACB is 52. Angle ACB is 52. Then angle CBD, it is 90 degree. As it is 90, and the same way this is also 90. Angle A, 52 plus 90. I will tell you where it has proved. Plus 90 plus angle, last angle which you have to prove, which you have to find, angle ADB. Angle ADB is equal to 360 degrees. This 90, this angle B and angle A, it is proof in tangent theorem, which earlier I had proved that it is 90 degree perpendicular. So it is tangent. Tangent theorem. G-E-N-T, tangent theorem, T-H-E-O. I guess the spelling is correct. Yeah, then we can solve it. Angle, so add this all and remaining ADB. So 52, 90 plus 90 is equal to 180. 90 plus 90 is equal to 180. 180 plus 52 is equal to 232. So 232 plus angle ADB. ADB is equal to 360 degree. So what we will do? What I will find angle ADB? 232, right? So angle ADB is equal to 360 minus this 232 is in positive side. When it's cross the is equal to sign, it becomes negative. So it will be 232. So what will be the answer? Angle ADB is equal to 128. So this will be 128. I hope the example is clear to you. If any doubt is there in this example, you can comment down to the video so that your problem will be solved. That's it for this video. For this lesson, concluding the lesson. So which is important. So mainly theorem and the solved example means which you will get how to solve the examples from this lesson. So that's it for this video, for this lesson. Okay, thank you. Jai Hind.